Right, let me state basic proportionality theorem or Thales theorem as follows. If a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, the other two sides are divided in the same ratio. Let us state once again. If a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, that means in different points, the other two sides are divided in the same ratio. This is what we're going to prove in this session. Consider a triangle ABC and draw a line parallel to the side BC to meet other two sides, that is AB and AC, at D and E respectively. So what I mean is a line DE is drawn parallel to BC to meet the remaining sides other than BC at D and E respectively. So according to the statement, what we have to prove is the ratio AD to DB must be same as AE to EC, that is AD by DB is equal to AE by EC. So to prove that fact, we need to do some constructions. So first join B and E, that is join BE, and after that join CD. And again draw a perpendicular from D to AC to meet AC at M, that is draw DM perpendicular to AC. In the same way, draw a perpendicular E to AB to meet AB at N, that is EN is perpendicular to AB. These are the constructions that we need to make to establish our theorem. Now we are able to see three different triangles. One is on the upper portion and two more triangles just below the triangle, I should say triangle ADE. So we find triangle ADE and triangle BDE and triangle CDE, three triangles, and we are going to deal with them. So here is the more clearer way to understand those three triangles. Yes, one is on the proportion triangle ADE, and one is on the left side triangle BDE, and one is on the right side triangle CDE. Remember that we are going to deal with these three triangles and we are going to find their areas. This is the central theme of this theorem. So we need to find the areas of these three triangles, and we find certain ratios to prove this theorem. So our ultimate aim, right, as I said, we are going to find areas of triangles. Yes, we have so many formulas to find area of a triangle. Among those, we often use area of a triangle is equal of base into height. So that's what we're going to use here also. So first let us find area of triangle ADE. So for this we need to find a base as well as its corresponding altitude. Yes, for triangle ADE, if we take AD as its base, and we can take EN as its altitude, don't we? So area of triangle ADE is equal to half AD into EN. In the same way, we also find area of triangle BDE. However, here we take DB as its base and again EN as its altitude, right? So area of triangle BDE is equal to half DB into EN. So likewise, we find area of triangle ADE and area of triangle BDE in the first case. Right, we found the area of triangle ADE and area of triangle BDE, and we are going to find the ratio of those areas. So area of triangle ADE by area of triangle BDE is equal to half AD into EN by half DB into EN. So we see that here half of gets cancelled, EN and EN gets cancelled, and we are going to have AD by DB. Thus, as a first result, we obtained area of triangle ADE by area of triangle BDE is equal to AD by DB. As a second case, again we try to find area of triangle ADE, but this time we take AE as its base and DM as its altitude. However, we know that in whatever way we find the area of a triangle, the area remains the same. So this time area of triangle ADE is equal to half AE and its corresponding altitude DM half AE into DM. So again we are going to find area of triangle CDE. We take EC as its base and dm as its altitude, as we have seen in the previous case. So now area of triangle CDE is equal to half EC into dm. So likewise, we found the areas of triangle ADE and CDE, and again we are going to find the ratio of areas of these two triangles. So as we thought of area of triangle ADE by area of triangle CDE is equal to half AE into dm by half EC into dm. Half of gets cancelled, dm gets cancelled, and we're going to have AE by EC. So area of triangle ADE by area of triangle CDE is equal to AE by AC. This is what our second result, or you can say second case. Right, we found two ratios or results, whatever you call. Those are area of triangle ADE by area of triangle BDE is equal to AD by BD, and again area of triangle ADE by area of triangle CDE is equal to AE by EC. So if we observe carefully, if you have a careful look at it, forget about those on the right side of the results, but try to focus on the left side of each result. In the first result, we have triangle ADE, area of triangle ADE in the numerator, in the denominator area of triangle BDE. In the same way, in the second result, we have area of triangle ADE in the numerator as above, as in the above result, and but area of triangle CDE in the denominator. So here what I'm concerned with is area of triangle BDE and area of triangle CDE. So let me understand about the areas of these two triangles. Yes, this is what I'm bothering about, the areas of triangle BDE and triangle CDE. Yes, they look as if they are same. That means they have equal areas. However, we should not conclude in a blunt manner, but we have to produce an evidence or a supporting statement to say that areas of those two triangles are equal. So we need to find such fact. We need to find such supporting fact to make sure that areas of these two triangles are equal. To understand the areas of BDE and CDE, let me show you our original diagram in an upright manner. So here you can clearly see that these two triangles lie on the same base, as well as they are in between same parallels. So this reminds me one beautiful fact what we have learned in our earlier classes. So triangles on the same base and between same parallels are equal in areas. So this is the fact that we have already proven. This is a fact which was already proven, and we are going to use it as our supporting statement. So obviously what we are looking for is arrived. So area of triangle BDE is equal to area of triangle CDE. Coming back to the ratios, those were found earlier. That is area of triangle ADE by area of triangle BDE, which is equal to AD by BD, and area of triangle ADE by area of triangle CDE, which is equal to AE by AC. Now, what have been looked different in our ratios, in our left side of our results, that is area of triangle BDE and area of triangle CDE. Now they are equal. So left hand side of our each result is equal. Therefore, right hand side is also equal. That is AD by BD is equal to AE by EC. Thus, we have arrived at the desired conclusion, that is, in a triangle, if a line is drawn parallel to a side to divide other two sides in distinct points, then the two sides are divided in the same ratio. So this is Thales theorem. This is popularly known as Thales theorem, and its original name is basic proportionality theorem. Learn it now. I think you can easily learn it, and don't forget to practice. In your examination, you may be asked like this: state and prove basic proportionality theorem, and state and prove Thales theorem, or sometimes he gives you the statement and asks you to prove. So in the next slide, I'm going to show you the entire proof, which is in a constructive way. You just copy it and you just write it, practice it after seeing all this video, and don't forget to share your friends. In whatever way, learning is important. Don't forget to share your friends and ask them to watch it completely, and ask them to further share it to their friends.